It is very hard for archaeologists to explain how that was done.
That's why I'm more interested not in how the Egyptians built the pyramids.
A hole in the ground that shouldn't exist. It's barely wide enough for one person to stand in, 30 feet deep, cut straight down into solid granite, one of the hardest stones on Earth. And the walls of that hole are covered in tool marks, so smooth, so evenly spaced, that when researchers finally ran the data through an AI model built to recognize industrial cutting patterns, it didn't say hand tools. It didn't even hesitate. It flagged the marks as a near match for machine-grade rotary cutting, the kind of precision we associate with diamond blades and factory equipment, not people swinging rocks 4,000 years ago. Now, before you assume this is another "aliens built the pyramids" video, it's not. Stay with me, because the real explanation is stranger, more human, and honestly more interesting than aliens. But to get there, we have to talk about a quarry in Aswan, a giant stone obelisk that was abandoned mid-carve, and a question that has quietly been dividing archaeologists for years. Did the ancient Egyptians know something about cutting stone that we still don't fully understand? By the end of this video, you'll understand exactly why that question refuses to go away. Before we get into it, if you're into ancient mysteries, unexplained engineering, and the moments where history and technology collide, hit subscribe and tap the bell. This channel lives for exactly this kind of rabbit hole, and you don't want to miss the next one. Also, drop a comment when you're done. I want to know what you think really happened here. Let's get into it. About 500 miles south of Cairo, near the modern city of Aswan, there's a stretch of desert that most tourists walk through in under 10 minutes. At a glance, it's unremarkable. Broken slabs, half-buried boulders, sand drifting over stone that's been sitting exposed to the sun for thousands of years. But get close, and I mean close enough to run your hand along the rock, and something starts to feel off. This is granite, not limestone, not sandstone. Granite is one of the toughest natural building materials on the planet, sitting around a 6 to 7 on the Mohs hardness scale. For comparison, a standard steel knife blade sits around 5. Working granite by hand is brutal, slow, and unforgiving, which is exactly why, for most of history, builders avoided it, unless they had no choice. The ancient Egyptians didn't avoid it. They quarried it by the ton. And when you look at the surfaces they left behind, you find long, curved grooves running across the stone in strangely consistent arcs, almost like something was dragged or spun across the surface in one continuous motion. No jagged stop and start. No obvious hesitation mark. Just smooth, repeating lines. The first time most people see this up close, they have the same gut reaction. This looks machined. That instinct is the whole reason this mystery exists. Here's what mainstream Egyptology has said for well over a century, and to be fair, it's not a bad theory. The leading explanation is that ancient workers used dolerite pounders, extremely hard, rounded stones, to literally hammer the granite into shape through repeated percussion. Thousands of strikes, over weeks and months, slowly wearing the surface down into the desired form. Archaeologists have found actual dolerite bowls at Aswan. This isn't speculation. The tools are real, and they're sitting in Egyptian museums today. For finer, straighter cuts, the leading theory shifts to copper tools combined with an abrasive, most likely quartz sand. Copper on its own is far too soft to cut granite, but copper saws dragged back and forth with wet sand packed into the cut can slowly grind through even hard stone, the same way a jeweler today might cut a gemstone using a soft blade loaded with abrasive grit. Egyptologists have tested this. It works. It's slow, painfully slow, but it works. And it matches marks found on other Egyptian granite artifacts. So, on paper, the mystery should be solved. The problem is, Aswan doesn't fully cooperate with either explanation. And that's where things start to get genuinely interesting. A few independent researchers, some archaeologists, some engineers with no formal Egyptology background at all, decided to actually test the pounding theory instead of just accepting it. They built replica dolerite hammers. They brought in people with real physical strength and stamina, and they pounded granite blocks for hours, trying to recreate what's on the walls at Aswan. What came out the other side was rough, uneven. Some strikes bit deep, others barely marked the surface. Fatigue set in fast. Within the first hour, grip and rhythm started to drift, and the marks got messier, not more consistent. That's not a criticism of the workers in that experiment. That's just what human bodies do. Fatigue is real, Muscles aren't machines. Now compare that to the actual Aswan cuts, where researchers using 3D laser scanning have measured groove spacing and curvature that stays remarkably consistent across long stretches of stone, sometimes with variation low enough that it genuinely surprised the people measuring it. That's the tension at the heart of this video. The theory says, tired humans with hammers and sand. The stone, in places, looks like something closer to a single, uninterrupted motion. So which is it? This is where things get interesting, and where our headline comes in. A few years ago, a small group of researchers experimented with something new. Instead of relying purely on human eyes and human assumptions to interpret the tool marks, they fed high-resolution 3D scans of the Aswan cuts into an AI pattern recognition model, in this case, Grok, and asked it a simple question. Based purely on the geometry of these marks, the curvature, the spacing, the consistency, what kind of tool or process produced them? They didn't tell it the marks were ancient. They didn't tell it where the stone came from. They just gave it the shapes and the measurements, and asked it to compare them against everything in its training data, hand tools, ancient implements, and modern industrial processes alike. The response wasn't primitive hand tools. The model flagged the pattern as closer to what you'd expect from a controlled rotary or abrasive cutting process, something with consistent, repeated motion, the kind of signature you'd usually associate with a machine rather than a fatigued human arm. Now, and this part matters, an AI making that comparison doesn't mean ancient Egyptians secretly had power tools. What it actually means is simpler and, honestly, more revealing. The marks are more geometrically consistent than we'd expect from purely manual, muscle-powered work. That's not proof of lost technology, but it is a legitimate, measurable anomaly. And once you notice it, it's hard to unnotice. If the story stopped at the marks look unusually smooth, this would still be an interesting video. But there's one detail at Aswan that pushes it further. Scattered through the quarry are narrow shafts, deep, tight vertical cuts, some plunging over 30 feet down, barely wide enough for a person to stand in comfortably. Here's the problem. The pounding hammer method depends on swing room. To generate enough force to chip away at granite, a worker needs real space to draw a hammer back and bring it down with momentum. Most estimates put that at close to 2 feet of clearance, minimum. Inside these narrow shafts, that clearance simply doesn't exist. And yet the walls of these shafts show the same style of curved, even cutting marks found in the open quarry above. No visible drop in quality. No obvious sign that a cramped workspace made the job harder. So either the Egyptians had a technique for working in tight, vertical shafts that didn't require a full hammer swing, something more like a controlled grinding or drilling motion, or our understanding of exactly how they used their known tools in confined spaces is still incomplete. Both of those are legitimate, non-fringe possibilities that serious researchers have actually proposed. Neither requires ancient aliens, but both require admitting the textbook explanation is, at minimum, missing some details. If there's one object at Aswan that stops visitors in their tracks, it's this one. Still attached to the bedrock where it was carved, lying exactly where it was abandoned, is what would have been the largest single obelisk ever attempted in ancient Egypt, estimated at well over 1,000 tons if it had been completed. It never was. The official explanation is straightforward. A crack developed in the granite during the carving process, and the project was abandoned as a structural failure. That's plausible. Cracks in massive stone blocks are a real risk, and Egyptian quarry workers absolutely would have recognized a compromised block when they saw one. But here's the detail that keeps drawing researchers back. Cutting marks appear to continue in sections beyond where the crack runs, suggesting work didn't stop the instant the flaw appeared. It continued for some time afterward. That raises a smaller, more human question buried inside the bigger mystery. Not, how did they cut granite, but why did skilled, experienced workers keep going on a piece they may have already known was compromised? Maybe they were hoping to salvage the effort. Maybe leadership overruled the crew. Maybe resources were already sunk too deep to walk away. We don't know. And that uncertainty is part of why this single object has become one of the most photographed and most debated pieces of ancient stonework in the country. Here's where the story stops being about one quarry. Similar cutting signatures, smooth, curved grooves, unusually consistent spacing, have been documented at other granite sites in Egypt, including elements of the Valley Temple near the Giza Plateau, one of the oldest and most enigmatic granite structures in the country. Different location, different blocks, similar handwriting, so to speak. That consistency is worth sitting with. A single skilled crew leaving distinctive marks at one site is easy to explain. People develop technique. Technique gets passed down, and a workshop's habits show up in its work. But when comparable signatures turn up at multiple sites, it starts to look less like the fingerprint of one small team and more like evidence of a shared method, a standardized approach to hard stone cutting that spread across the workforce of the era, whatever that method actually was. We don't have a surviving instruction manual. We don't have a diagram of the tool. What we have is the stone itself, quietly repeating the same story in more than one place. It would be easy to package all of this as proof of a lost advanced civilization, and a lot of content out there does exactly that. I'm not going to do that here, because it's not what the evidence actually supports. What it does support is something almost more impressive. The ancient Egyptians were better engineers, planners, and craftspeople than the popular imagination usually gives them credit for. We tend to picture ancient stoneworking as brute force labor, thousands of people hammering rocks until something takes shape. And there's truth in that. The manpower involved in Egyptian monument building really was staggering, with tens of thousands of workers organized in rotating shifts. But brute force alone doesn't explain consistent curvature across dozens of feet of granite. It doesn't fully explain cutting inside shafts too narrow for a hammer swing. And it doesn't explain why some of the oldest known cuts at these sites are, by several measurements, among the most precise. What it suggests instead is a level of technical sophistication, specialized tools, trained specialists, inherited technique passed down through generations of quarry workers that simply didn't survive in the written record, the way temples and tombs did. Craft knowledge is fragile. Unless it's written down or physically preserved, it can vanish within a couple of generations, even while the stone it produced sits there for millennia. That's a far more grounded conclusion than lost super technology. But it's arguably more haunting, too, because it means we've genuinely lost something real, not a fantasy. An actual body of practical engineering knowledge that an ancient culture developed, used, and then let slip away. So where does that leave us? We have a quarry with tool marks too consistent for the leading theory to fully explain. A network of narrow shafts that shouldn't have been workable with the tools history says were used. 1,000-ton obelisk abandoned mid-carve for reasons we only partly understand. And now, an AI model looking at the raw geometry of these cuts and flagging them as closer to a controlled, repeated process than to fatigued manual labor. None of that proves secret ancient technology. But taken together, it's more than enough to say the textbook version of this story isn't finished being written. Maybe the answer is a lost technique, a specialized rotary or abrasive method that never made it into any surviving record. Maybe it's simply that ancient craftsmen were more skilled, more organized, and more capable than we've historically assumed. Or maybe it's a combination of both, waiting on the next excavation, the next scan, the next AI model, to help connect the dots we've been staring at for 200 years. Whatever it is, the stone isn't going anywhere. It'll still be sitting in that Aswan quarry, waiting the next time someone decides to look closely enough to ask the question again. So, I'll ask you the same question. The researchers keep asking themselves, lost technique, underestimated skill, or something we genuinely haven't identified yet? Tell me what you think in the comments. I read every one. And honestly, some of the best theories on this topic have come from viewers, not researchers. If this kept you curious until the end, you know what to do. Like, subscribe, and I'll see you in the next one.